Hello everyone. Welcome to my YouTube channel Target 100 in Mathematics by Shivesh Kumar Singh. And today we are going to talk about a very interesting lesson which needs least practice. Means if concepts are clear to you, then no need to practice much questions and your answers will be always correct. Okay? Yes, I am talking about the chapter set theory. Okay, and today in this video we are going to discuss some basic things related with set theory. So let's start the lesson. See, in our everyday life, can you think about some words where we use the word set? Any word in your surroundings where we use the word set. Okay, I'm sure you are thinking some words correctly. Yes, I'm talking about, for example, say dinner set. Everybody has dinner set at home. Yes, we can say sofa set. Yes, everybody must have sofa set in their drawing room. Yes, same lemon set, book set, means so many things are there. Yes, where we use this word set. So what does it mean? For example, let's talk about sofa set. Okay, so sofa set means it's a type of specific chairs, means one long chair, one small chair, another small chair, and then one center table. Yes, so a set of specific objects is called sofa set. If I say that this is small chair made up of wood or plastic or anything, okay, so will it be the part of your sofa set? Then you will say no, it will not be the part of sofa set. Why? Because it doesn't match with the given design of another chair. Yes, so means it doesn't match the given criteria for a particular thing to belong to any particular category. Okay, so this is the basic and important thing for anyone to understand about the set. So what should be the meaning of the set? Set means it is collection of it is the collection of well defined objects. It is the collection of well defined objects. Now question arises here. You can ask this question that why don't we say it is collection of objects? Why we are using this word well defined? And my dear students, this is really very important in this reference. Okay, well defined. Well defined means, I will tell you this meaning also. What is the meaning of well defined? Means if for a given particular object, if for any particular object, you can say that yes, it will belong to the collection, or you can say no, it will not belong to the collection. Means when you are sure. So if for any particular object you are sure that it will belong to or it will not belong to, for anything, maybe for yes, maybe for no. But if you say maybe it may belong to the given collection, it may not belong to the given collection, means if you have doubt, then it will not belong to the, this collection will not be the well defined. Okay, now let's talk about some examples. If I say collection of good students, collection of good students of your class. Okay, so just take your example, collection of good students of your class. So if I talk about your teacher, if I talk from your teacher about you, that whether you are a good student or no, what he or she will say? Maybe you are very good in his subject, so he will say yes, he is very good student. But unfortunately, if you are not good in his or her subject, then he or she will say no, he is not a good student, but he is average. Yes, maybe you are very good in sports. So if I take your feedback from your sports teacher, then he will say yes, he is very good student. But if you are not good in sports and you are good in academics, then if I talk about you from your sports teacher, then he will say okay, he is okay in other activities, but he is not good for sports. Okay, so whenever human dealing is involved without any condition, then every time it will not be well defined. Okay, and it means this type of collection will not be the set. It is just a collection only. Okay, now another example, you can say collection of good batsmen in India. Collection of good batsmen in India. For example, okay, see, just now I told you, if there is any human category involved and without any condition, it means that collection will not be the well defined collection. But let's try to understand with the example. Here we are taking collection of good batsmen in India. So why this is not a well defined collection? See, if I say, for example, okay, Virat Kohli. Okay, do you think that Virat Kohli will be in this collection, in the good batsman collection? Definitely you will say yes, he will be. Okay, but now consider two situation. Okay, imagine two situation. First situation is India needs 50 runs to win. Okay, and only Virat Kohli with his partner is on the crease. Only just last wicket is left. So Virat Kohli took the chance, and then by hitting fours and sixes, India won the match. Okay, so definitely he is going to the best one till the next match at least. Okay, now consider another situation. Something final match is going on for some trophy, and only 2 runs are required to win the match. And again, same situation. Virat Kohli along with his partner is on the crease. Virat Kohli took the chance, and then by chance he was bowled out. So India lost the match by 1 run. So what will happen? Everybody will criticize him. He should not do like that. He should not do like this. Yes. So till next match, he will not be good. Rather, he will be the worst if he is losing the final match. It is just a scenario I am telling you. Okay. So definitely this is not the fact, but you know the system. So many criticism will be there. So many things. Yes. So this type of collection will also not be the well defined collection. So if it is not a well defined collection, it means it will not be the set. Okay, now let's talk about some another examples. For example, say collection of all natural numbers. I am sure you know about the natural numbers. Natural number means the counting number which starts from 1. Okay, so collection of all natural numbers. So there is a specific category for the numbers. Okay, provided we know that category. Yes, so if I say, okay, 3/2, will it belong to this collection of natural number? You will say no, because 3/2 means 1.5, and no decimal number can belong to the set of natural numbers. Yes, if I say -2, will it belong to this collection? You will say no, because it is negative number, and a negative number doesn't belong to natural number. If I say 100, then will it belong to this collection? Yes, because it is a natural number. It is positive counting number. Yes. So for any particular example, you can say that yes, it will belong to the collection of natural number, or it will not belong to the collection of natural numbers. Yes. So it means it is a set, and set of natural number, it is denoted by n. Okay, so just for the denotion only, because these denotions will be required for you in further lessons. Okay, so set of real number means R. It is set of real numbers. Okay, now set of integers means Z. It is set of integers. Then set of natural numbers, just now I told you by n. Okay, it is set of natural numbers. What else we have? Yes, whole number, W. Okay, set of whole numbers. Okay, so these are the various categories of the numbers which will be used in the upcoming questions. I am sure this thing is clear to you. Okay, so I am sure you understand the concept behind the well defined object, well defined collection, and just a collection only. Okay, so every set, it is a well defined collection. Okay, now let's talk about some representation of the sets. So how do we write the set? How do we represent the set? any set is represented by any capital letter, say for example A, B, C or X, Y, Z, anything, okay? So any capital letter, and then its elements are written in between curly brackets separated by comma, separated by comma, and of course without repetition. You will not repeat the elements in the set, and if it is repeated by chance in the question, then you will count it for once only, okay? You will not count it for two times. For example, if I say B is equal to 1, 2, 4, 1. So if I say how many elements are there in B, you will not say 1, 2, 3, 4. No, this is the wrong answer. Why? Because 1 is written two times. So you will not count this one. So how many elements are there? 1, 2, 3 elements only. So how do we represent the set? Any set is represented by any capital letter and its elements are written in between curly brackets separated by comma and without repetition. Okay? Now, there are some types of symbols, special symbols now you are going to study. Maybe this is for the first time because these symbols were not in grade 10. Okay? So, if I say 1 is an element of A, 1 is an element of A. What you will say, yes or no? Yes, it is an element of A. Why? Because we can see 1 here. Yes, or you can say like this also, 1 belongs to A. 1 belongs to A. This also conveys the same meaning. Yes. So in place of writing this big word again and again, what we can do here? We can write 1 belongs to A. This symbol is for belongs to. In name, as a name, you can say it is epsilon. Okay, maybe in physics also you use this. So, but here we will say belongs to. Okay, so 1 belongs to A. Now, if I say 5 belongs to B, what you will say, yes or no? Of course, you will say no because you cannot see 5 here. Yes, so how you will write? 5 does not belong to A. So, you will write like this, belongs to, and then cut it. Okay, so 5 does not belong to. This meaning does not belong to. Okay, so this is some symbol for the elements, especially for the belong to and does not belong to. Okay, now we will see how to represent the sets. Okay, how we are going to represent the set. So first is, there are two types of representation. First is called roster form. First is called roster form. Okay, my dear students, remember one thing. Sometimes by mistake you write like this, roster form. This is of course wrong. Okay, this roster conveys something different meaning. Yes or no? Okay, write its meaning in the comment, this second one. Okay, I want to know that how many of you can see this thing and how many of you will write in your notebook like this. Okay, roster form. What is the meaning of roster form? In this we write all elements in the set. We write all elements in the set. Okay, as I have told you just now, separated by comma and without any repetition. For example, we can say A is equal to A, E, I, O, U. Okay, you can see I have written set of vowels. What we say? Set of vowels. Okay, or more specifically you can say set of vowels of English alphabet. Yes, so this is roster form. So in roster form what we do? We write all the elements in the curly brackets separated by comma. Now, can you think any drawback of this presentation? What's the problem? See, if we are going to study second type of form, second type of representation, it means there should be some problem in the first type of form, first type of representation. Yes, so what can be that problem? First problem is, it is time consuming. It is time consuming. Now you will say, Sir, how much time it will take? Only just few seconds, only A, E, I, O, U. But no, if you have to write a big set, for example, all the students of your school, of a school. So for example, suppose there are 4,000 students in a school and you have to write the names. Do you think it will be possible in one day even? No. Okay. So this is time consuming process. And another problem from this will be some elements can be missing. Some elements can be missing. Okay. Now, so these are basically drawbacks. These are the two drawbacks of roster form. So keeping this in factor, we are going to introduce another form of representation of sets, and that is called set builder form. That is called set builder form. And what is that set builder form? You see, in set builder form, what we do, normally we write a capital letter for the set and then a small letter. Usually we write X. You can write anything, but normally we write X, such that, okay, see, students, in some of the books you will not see this colon. In place of colon, you will see a line like this, okay, like this. It is also meaning the same, such that, okay, but normally I write like this, so it's okay. You just understand it. Okay, so this is called such that X is a vowel. Okay, now what you have to do in set builder form, you will take a small letter here and the property based on the small letter, so that only the required element may belong to the collection. Only the required element, what does it mean? If you write by chance X such that X is an English alphabet, X such that X is an English alphabet. Okay. So what's the problem here? English alphabet, there are 26 alphabets. Yes. But in that set, if you remember, I have written only 5 letters. A, E, I, O, U. Yes or no? Okay. So this will have some extra element also. That's what this is not correct. Yes. Now, like this, you will write only the specific property, so that only the required element may belong to the set. Let's talk about another example. Suppose we have A is equal to 1, 2, 3, 4, 5 and so on up to 10. Okay. Now, this is in roster form. Yes. Question can be, write this in the set builder form, and definitely you are going to have such question in your exam, at least in first unit test. Okay. So we have to write in set builder form. So what we will do here, first you will write X, a small letter, and then what property you will write here for X? Can we write X is a number? Yes, we cannot write. Why? Because there are so many numbers, positive, negative, fraction, rational, irrational, so many numbers. Yes. What else we can write? X is a whole number? No, we cannot write, because here we don't have 0. Yes, and whole number has 0 also. So what we can write here? X such that X is a natural number. X belongs to n. Will it be the final answer? Did you say no? Very good. It will not be the final answer. Why? Because there are so many natural numbers, 100, 1000, 10,000, 1 million. Yes, but we have limit up to 10 only. So what you will write here? X such that X is a natural number and X is less than or equal to 10. Or you can write X is less than 11. Now this will be the complete answer in set builder form. Okay. Now you will definitely have one question from this. Okay. Now let's talk about one more example for this. Suppose it is given to us like this: 1 over 2, 2 over 3, 3 over 4, 4 over 5 and 5 over 6. Okay. Now we have to write this in the set builder form. So now think about this. This is not going to be the easy example, but if we think about this, we can write it easily. X such that, now you see, x is like a fractional number. Yes, some number is up and one number is down. So what relation you can see here between numerator and denominator? You can see numerator, whatever you have numerator, its denominator will be 1 more than the numerator. Yes or no? Yes, and there is a condition for the numbers also. N is a natural number and n is less than or equal to 5. This is the complete answer. Okay, x such that x is a number n upon n plus 1 because numerator is 1 smaller than denominator, or you can say denominator is 1 bigger than the numerator, and n is a natural number less than or equal to 5. Okay, now can we write this representation like this also? Because sometime I have seen this like this in one of the answer sheets. So student, they have written first down n here and then n minus 1 up. They say that okay, we have taken that numerator is 1 less than the denominator. So denominator I have taken n. So numerator will be n minus 1, where n is a natural number and n is less than or equal to 5. Will it be the correct answer, my dear students? Write in the comment that yes, this is the correct answer, or no, this is not the correct answer. Okay, so pause the video for a few seconds and think. Okay, now why this is not the correct answer? Because maximum value of n is 5. So if you will put here 5, so okay, let's talk about from 1. So because smallest value of natural number is 1, so 1 minus 1, it will be 0 upon 1 means 0. Can we see 0 here in the set? No, it means this property is not correct. So what you will do here? You will write here n is less than or equal to, yes, did you say 6? Okay, by using 6, you will get the last number. But what about the first number? Still it will be 0. So it means this this method is wrong. And if you want to make it correct, what you will do? You will write n belongs to n such that n lies from 2 to 6. Okay, you will not consider as 1. Now you can check. First value of n will be 2, so it will be 1 over 2, then 2 over 3, 3 over 4, 4 over 5 and 5 over 6. That's all. Okay, see, like this if you check the property, then easily you can find the answer. Okay, now let's talk about some more examples which are very important for your exam. For example, say they say a is equal to minus 1 and plus 1. Only two elements. Okay, so some of the students by mistake they write x such that x is an integer where it is minus 1 less than or equal to x less than or equal to 1. Is it the correct answer? No. Why? Because from minus 1 to 1, we have minus 1 and plus 1. It's okay, very good. But where is 0? 0 also lies from minus 1 to 1. Yes, and 0 is missing. So this is not the correct answer. So what you will do here? You will think about another property. Okay, so what property you can write here? I will not waste your time. I will tell you x such that x square minus 1 is equal to 0. Now you can see it is a quadratic equation, and if you solve it, then x square will be equal to 1. So x will be equal to plus minus 1. Okay, so what I told you in this video, I explained you what is a set, what is a well-defined collection, and then what is roster form, what is set builder form, and how to write from set builder to roster or roster to set builder. Hope you understood this topic. And my dear students, if you think that such videos will increase your knowledge, please like and subscribe my channel and share with your friends. Thank you.